Okay, this is another homework video. This is 10.3.29. As I suppose you can all read, I'll try to speed through this paragraph here. It says the average daily volume of a computer stock in 2000 was the mean was 38.4 million shares according to a reliable source. A stock analyst believes that the stock volume in 2004 is different from the 2000 level. Based on a random sample of 40 trading days in 2004, he finds the sample mean to be 27.4 million shares with a standard deviation of 14.7 million shares. Test the hypothesis by constructing a 95% confidence interval. Okay, so let's do that. And first we gotta kind of state the hypothesis for the test as I have written, and it is this, because we're proving if it has changed, because this is what it was, and we found that it's now 27.4. So we're going to see how that works out. So the first thing we got to do once we've stated the hypothesis for the test, as you can tell, it's rather late, and I might have a speech impediment. Construct a 95% confidence interval. So how do we do that? Well, we do have to say about the sample mean of stocks traded in 2004. Well, let's find the critical value first, and that's that all familiar symbols you see there. So we're going to take that. Essentially, we had a 95% interval, so we subtract 0.95 from 1. Divide that in half, get 0.25. Then we take out our trusty and beloved, not that one, our beloved t-distribution chart. And we know, since we just found it was about, what, 0.025, and we know that there are 40 trading days, so our degrees of freedom are less than that, just one less than that. Way down at the bottom here, it's gonna be, hold on, coming, and let's see, that's 2.023, and let's see if that's the number I have written down. Oh, so it is. So now I've also taken the numbers out of the equation for us to make it easier. So n is 40, the mean is 27.4, the standard deviation rather is 14.7. We simply plug these values into the lower and upper bounds. If you look closely, the only difference in the equations is the minus for the lower bound and the plus for the upper bound. So let's go ahead and plug and play these values here, and for the lower bound we get 22.698, and then for the upper bound we get 32.102, and I wrote the confidence interval out. And as you can see it says 10 to the 6. I couldn't fit million in there, so I wrote that instead. It's just simple scientific notation. So now the last part of this thing asks you to determine if the researcher will need to reject the hypothesis, the null hypothesis. Well, for our purposes, he sure as hell's gonna, because, let's see here, the value we were given, let's see, where is it here? 27.4. Well, not 27.4, what am I saying? Mu does not fit within the concept. I'm losing it here, folks. It is currently 2:24 in the morning. I want to finish these off before Monday, and I think I wrote it down wrong. Because, or am I right? No, I'm absolutely right. I'm just late in the evening. So the mu we're talking about is 38.4, and it clearly does not fit in between that number and that number. So we do not, it does not fall in the confidence interval, so we reject the null hypothesis. Thank you for bearing with me, folks. Have a nice night or day.